Let's consider this question on differentiation, implicit function. WASSCE June 2011 question 12a. If x squared plus y is equal to py into bracket 1 plus s squared, where p is constant, find dy on the x. So the question is s squared plus y squared equal to py 1 plus s squared. And you say p is constant. And you are supposed to find dy on the x. This is implicit. Okay, so first of all, let's expand this. Okay, so that we have s squared plus y squared equal to py times 1 is py, and then plus p ys squared. Okay, so now that we have this, then we are going to make dy on the x the subject. Okay. So the differentiation of s will give us what? 2x. Alright, plus y squared will give us 2y dy on dx. Okay. Then here the constant here p is multiplying what? It's multiplying y. And here we are going to apply what? The product rule. Okay. So you differentiate p, the constant, and then you maintain what? You maintain or you multiply by y. Differentiation of p is what? Is 0. Okay, so when we multiply by y, it will still be 0. So as you are privy to, when you are differentiating and then you are applying the product rule, normally the constant part, if you differentiate to be 0, so you don't waste your time on that. So what we have to do is to differentiate the y, and that will give us dy on the s. So and then multiply by p. So we have p dy on what? Dx. Because when you differentiate the p, it will be 0, and then make this whole thing to be 0. Okay, so we have p, we differentiate y and multiply by, so p dy on ds. Okay, then here too we have y and then s squared. Because p is constant, our focus will not be on the p. Okay, I know you know the reason why. So we have y and then s squared. So we are going to differentiate y. When you differentiate y, then we multiply by what? The p and the s squared. So when you differentiate y, we get dy on the x. So we will have ps squared dy on what? The x plus. So we differentiate s squared, then we multiply by py. So the differentiation of s squared is what? Is 2x. Okay, so 2x, then multiply by py. Alright, so here it means that we have applied what? The product rule. Okay, so when you differentiate s squared to give me 2s, y squared give me 2y dy on the s. P is constant, so differentiate the y. Differentiation of y will give you dy ds, multiply by the p, plus then you differentiate y, which is dy on the s, then multiply by ps squared. So ps squared dy on the s. Then you differentiate s squared, that is 2x, then multiply by py, so 2x py. All right. So let's continue. Our aim is to make what? Dy and over the s the subject. So we will take dy over the x, we will take it to one side and then bring the other one to the other side. Okay, so I'll have what? 2y dy on the x, okay, minus p dy on the x, then minus ps squared dy on the x to be equal to, so what is left is what? 2x py, then we bring the 2s minus 2x. Okay, so how many terms do we have? 1 2 3 4 5. 1 2 3 4 5. So we bring the dy on the s at one side. Okay, so this one go here to be minus, that's what we have here. This one go here to be minus, then 2s py will be at the right hand side. Then we take the 2s to come here to be minus 2x. All right, so here we can factorize dy on the s out. So we have dy on the x, then here will give us a 2y minus p minus ps squared. Okay, equal to here too, if you like, you can factor 2x out, so that I have for py minus 1. All right. So 2x out, so py minus 1. All right. So what we do is to divide through by 2y minus p s squared. So our dy on the x will be equal to 2x py minus 1, all divided by 2y minus p s squared. So this is our answer. All right. So when you differentiate the implicit function here, you get 2x into bracket py minus 1, all divided by 2y minus p squared. I believe you got it, and this is so simple to do. I will see you again in our next lesson. Bye bye.